Now let's talk about the assignment model using linear programming. So in Excel also we can consider the assignment model as a special case of the transportation model. So let's using the fix-it repair store case as example. This is a simple store, in which case we were told that there are 3 projects need to be finished immediately, and we have 3 workers. Each one can work on any one out of the 3 different projects. But if we assign different person to different projects, that comes with the corresponding different cost terms. So our purpose here is try to minimize the total costs by assigning each person to one specific project to finish all 3 of them. Okay, in Excel, so let's first load the cost information. We have project 1, and project 3. So this is the cost data. The 3 workers are Adams, Brown, and Cooper. The cost information given in the table here. We simply load the information into Excel spreadsheet. Okay, now our decision variables are the assignment decisions. Let's put a red color box to stand that the values located in the box are our decision variable values. So initially we say we assign nobody. Okay, our purpose is to minimize the total costs. So use some product function it's very easy to calculate this total cost value. So just pay attention, and in our case here, our decision variables we can specify like x sub I. So I stands for from 1 to 3 stands for different person, and J stands for different projects, also takes value from 1 to 3. But pay attention, for assignment model, these decision variables, all of them should be binary variables, which takes value either 0 or 1. When it takes value 1, it means the ith person is assigned to the J's project. Otherwise, it equals 0. And our constraints, according to this case material, is that for each person, for each row, the summation of each row, so like x11 plus x12 plus x13 should equal 1. For 3 of them, the same constraint here. And also for each project, the assignment should be stated like x11 plus x21 plus x 3-1 equals 1, which means every project has been assigned one person to work with. And also, of course, the non-activity constraint here, because we already set our decision variables to be binary, so definitely they are all non-active. And then we load the constraints here. We say, so assigned project for each person, simply take the summation here. Required that everyone works on one project. So for each project, how many people are assigned to work on it? Also, we'll take the summation of the column total. Then they should equal to the required worker numbers. So here all three need only one person to work with. Then we go to solver. We say our target cell is the total costs. We try to minimize it. So just pay attention, especially pay attention to the case requirements, to the case contents here. In our case here, we try to minimize total costs. Suppose you are the owner or the manager running this repair shop. So definitely you want to minimize the labor costs. And also, suppose you are a manager of a consulting company, and we try to assign our different teams or different workers to our different clients. In that case, we try to decide how to charge our clients to maximize our total revenue. So in that case, you should check the maximization box here. So just pay attention. Different cases may assign different totally different objective function. By changing our decision variables, so select the range of this matrix here. Then our constraints, first of all, for assignments model, so pay attention, first of all, our decision variables should be binary. Select BIN, stands for binary. So in this case, we force solver when try to search for the best choice, the optimal solutions. The solver will force all the values assigned to our decision variables here into this range to be either 0 or 1. Then for each person, how many projects are assigned should equal to the required value, the specified value. So in our case here, everyone works on only one, so we simply put 1 here. Of course, you can simply type 1 in this box here. And of course, in certain cases, if we say everyone should be assigned to work on 2 projects, or at least 1 project, so you have to change the inequality sign here, larger than or equal to 1, or set equal to 2, in which case. And our case here is very simple, so we simply use it as example. In this case, everyone works only on 1 project, and every project only needs 1 person to work on. So after we specify the case here, and also please check the box here, and then select the simplex linear programming algorithm. Hit OK button. Then you see our optimal solution is to assign Adams to work on project 3, assign Brown to work on project 2, and assign Cooper to project 1, which will bring us the minimize the total costs of $25 in this case. So just pay attention. This case, as we discussed already, it can be expanded to deal with different scenarios, like say everyone has to work on at least 2 projects or 3 projects, and every project maybe need like more than 2 persons, or sometime like in our case here, maybe project 2 needs 2 persons to work with it, or maybe project 3 need 3 of them to work on that. So in that case you need to change like required value here and accordingly change the values required on this side. So just pay attention. Assignment model is very simple, and also it's very straightforward if we list our model in this format. It's similar to the transportation model, as you can see.